Hey guys, welcome to brainAttic. Today we have another set of challenging problems from complex numbers. Problems of this type often appear in the engineering entrance examinations. If you do want to give it a try, you can pause the video and give it a try. Otherwise, let us continue solving the problem. A relation R on the set of non-zero complex numbers is defined by Z1 relates to Z2 if and only if Z1 minus Z2 by Z1 plus Z2 is real. Then R is A equivalence, B reflexive, C transitive, D none of these. In the second question you see, if a complex number Z satisfies amplitude Z is equal to 1 and argument Z minus 1 is equal to 2 pi by 3, then option A, argument Z square plus Z is equal to pi by 2, option B, Z is equal to minus omega square, option C, Z is equal to minus omega, or option D, amplitude Z minus 1 is equal to 1. Let us begin solving the first problem. In the first problem, clearly, Z relates to Z as Z minus Z by Z plus Z is equal to 0, which is a real number. Is a real number. Hence, the relation is reflexive. Also, the relation R is symmetric if Z minus 1 by Z1 minus Z2 divided by Z1 plus Z2 is a real number, then Z2 minus Z1 divided by Z1 plus Z2 is also a real number. Now, if Z1 is equal to x1 plus iota y1 and Z2 is equal to x2 plus iota y2, then Z1 relates to Z2 if and only if x1 minus x2 plus iota y1 minus y2 whole divided by x1 plus x2 plus iota y1 plus y2 is a real number. This is identical to x1 minus x2 plus iota y1 minus y2 taken product with x1 plus x2 plus iota y1 plus y2. And in the denominator we will have x1 plus x2 whole square plus y1 plus y2 whole square is a real number. This is again identical to, we equate the imaginary parts of the above equation to 0 and we have y1 minus y2 into x1 plus x2 minus x1 minus x2 into y1 plus y2, which is equal to 0. This is identical to x1 by y1 is equal to x2 by y2. Similarly, if we do the same exercise, for z2 is equal to x2 plus iota y2 and z3 is equal to x3 plus iota y3, then Z2 relates to Z3 if and only if x2 by y2 is equal to x3 by y3. So, if Z1 relates to Z2 and Z2 relates to Z3, then x1 by y1 is equal to x2 by y2 is equal to x3 by y3, which is x1 by y1 is equal to x3 by y3, which implies z1 relates to z3. So, the relation R is transitive. Hence, the relation R is equivalence. So, if you look at our options, since this is a one or more options are correct type question. So we have all the three options A, B and C. Now going to the next problem. If complex number Z satisfies amplitude Z equal to 1 and argument Z minus 1 is equal to 2 pi by 3, then we have few options. Again, this is also a multiple option type question. So we'll solve this question. So amplitude Z equal to 1, that is Z lies on a circle whose center is at origin and the radius is 1. The argument Z minus 1 is equal to 2 pi by 3. So Z lies on a line emanating from 1, 0, making an angle of 2 pi by 3 with x axis or the real axis. So I have a figure for this. I'll insert it. So the diagram would look something like this. Here we have the circle Z equal to 1. There's a line PQ which makes an angle 2 pi by 3 with the x-axis and intersects at point P. So now we can say that angle PQX is equal to 2 pi by 3. This will imply that angle PQO is equal to pi by 3. We see that both are radius of the circle, so OP is equal to OQ. So triangle OPQ is an equilateral triangle. Therefore, which means that OP is equal to OQ is equal to PQ. So the amplitude of Z is equal to amplitude of Z minus 1 is equal to 1. Now argument Z is equal to 60 degree. We are seeing this, right? So Z is equal to cos 60 degree plus iota sine 60 degree, and this we know as omega minus omega square. Minus omega square. Therefore, Z square is equal to omega power 4, which is nothing but omega. Therefore, Z square plus Z is equal to omega minus omega square. Finally, minus 1 plus I root 3 by 2 minus 1 minus I root 3 divided by 2 is equal to I root 3. Therefore, this implies the argument of Z square plus Z is equal to pi by 2. So we see all the options which are given to us, and we find that option A, option B and option D is correct. Thank you for watching this video. If you do like the video, hit the like button, subscribe to our channel, and if there are any feedback, please do give us. We will solve many more problems as like this. Do follow the channel. Thank you so much.